Hello, my name is Gary with HaveFunWithScience.com, and I have a question for you. What happens if you take an ordinary quarter and stick it on a piece of dry ice, which is frozen carbon dioxide? Let's find out. If you look closely, you can see that I'm literally melting a notch in the dry ice in which to place the quarter. Notice that you can actually see the quarter vibrating on the ice. It looks kind of funny because I only had one instance out of all my footage where you could easily see the movement of the coin. So I captured that image and duplicated it several times over so you can study it. So why does the dry ice scream when it comes in contact with metal such as a quarter? It was a hot 90-degree summer day when I did these experiments. So it was safe to say that the quarter was also around 90 degrees Fahrenheit. Since dry ice is negative 109.3 degrees Fahrenheit, or negative 78.5 degrees Celsius, that means there is nearly a difference of 200 degrees Fahrenheit between the dry ice and the quarter. The frozen dry ice sitting on the table begins to sublimate as soon as it is placed on the table. And that means it begins its transformation from a solid into a gas. Now that process is speeded up when I take a quarter and place it on top of the dry ice, because when I do that, I am literally making a wedge in the dry ice to make a place to sit the quarter. And where the quarter is touching the dry ice, it is making that transformation from solid to gas even faster. Like a boiling pot with a rattling lid on top of the trapped gas. There is newly formed gas behind the coin under pressure. When a sufficient amount of pressure is built up under the coin, it lifts up. And when the pressure is gone, the coin sits back down and rattles. This rattling and screeching process repeats itself until the coin cools down. One more thing, if you want the coin to rattle and it stopped, take the coin and dip it in some hot water and then put it back on the dry ice.